In this video, we are going to discuss about tidal energy. So let us start with ocean tide. Ocean tides are the periodic rise and fall of water level occurring twice in each lunar day. Tides occur due to gravitational forces of the moon and the sun on ocean water and are affected by spinning of earth around its axis and the relative positions of earth, moon and sun. The differences in the level of ocean water between high tide and a low tide results in the ocean tidal energy. This is the picture showing high tide and the picture showing low tide. Now let us see what is meant by tidal energy. During high tide, the level of water increases with reference to low tide level. The potential energy is higher during the high tide than the potential energy during the low tide. And the differences in the potential energy during high tide and during low tide, it is called tidal energy. Now let us see how the electricity is generated by using tidal energy. So to generate electricity with the help of tides, a dam is constructed in such a way that basin gets separated from the sea and a difference in the water level is obtained between the basin and sea. So in this picture we can see that a wall or a dam is constructed. Now what is basin? Basin, it is the region of the sea which is separated by the wall, which is separated from the sea by the wall called dam. A passage is kept in order to flow the water from sea to the basin or from basin to the sea. The constructed basin is filled during the high tide and emptied during the low tide, passing through the tunnel called sluice, and the turbine is mounted on that passage. So during the high tide, the water level rises, and as the basin is separated from the sea and there is only one passage kept between sea and basin to flow the water, that is called sluice. So as soon as the wall of the sluice is opened, the water starts to flow from sea to basin because of the potential head. and as the turbine is mounted in between this passage, it gets rotated and a mechanical energy is generated there. This mechanical energy, it is rotary mechanical energy, it is converted into electrical energy with the help of coupling electric AC generator to that turbine. The potential energy of the water stored in the basin is used to drive the turbine, which in turn generates electricity as it directly coupled with generator. Now, based upon the basin used, tidal power plants are classified into two types: single basin tidal power plant and double basin tidal power plant. So let's see the construction and working of both the tidal power plants, that is single basin tidal power plant and double basin tidal power plant. Now let's see the construction of a single basin tidal power plant. In this power plant, the power generation is periodically or it is intermittently. Power generation is during the high tide or it is during the low tide. Single basis tidal power plant, it consists of a basin which is separated from the sea by a wall called dam or deck. So here we can see that this one is the basin, this is sea. So these two are separated by this wall called dam or deck. The flow of water between sea and basin and vice versa is through the sluice. So this is the sluice through which the flow of water from sea to basin or from basin to sea is done. The rise and fall of a tide provide the potential head. The rise of a tide or fall of tide, it provides potential head. Single basin tidal power plant, it uses reversible water turbine. That means whenever the water flow from sea to basin or from basin to sea, the power generation, it is possible with the help of this reversible water turbine. Now let us see the operation of single basin tidal power plant. When the incoming tide sea level and tidal basin level are equal, the turbine conduit is closed. When the sea level rises and about halfway to high tide, the turbine valves are opened and the sea water flows into the basin through the turbine runner, generating power. This also raises the level of water in the basin. The turbine continues to generate power until the tide passes through its high point and begins to drop. The water head then quickly diminishes till it is not enough to supply no load losses. Bypass valve then quickly opens to let water into the basin to gain maximum water level. When the sea and basin water level are again equal, the valves are closed as well as the turbine conduit. The basin level then stays constant while the tide continues to go out. After sufficient has developed during the low tide, the turbine valves are again opened and water now flows from basin to sea, thereby generating again power. The plant continues to generate power till the tide reaches its lowest level, and again during the high tide water flows from sea to tidal basin, thereby generating power. So this cycle, it goes on continues during each lunar day. So in this way, the power generation, it is done intermittently during the high tide or during the low tide. Now let us see the construction and working of double basin tidal power plant. In the previous slide, we have seen the construction and working of single basin tidal power plant. The main drawback of the single basin tidal power plant is that it cannot generate power continuously. But a double basin tidal power plant, it can provide power continuously or on demand. It consists of two basins called upper basin and lower basin. So this is the sketch or schematic layout of the double basin tidal power plant. This one is upper basin and this one is lower basin. One basin is maintained always at a lower level than other. So this lower basin, it is always maintained at a lower level than the upper basin. A dam is constructed between the sea and basins. A dam is constructed between upper basin and sea, as well as between lower basin and sea, and between the upper basin and lower basin. A powerhouse is mounted in between the dam constructed between the upper basin and lower basin. Powerhouse means the equipments which are used to generate power or electricity. The equipments such as turbine and generator. The lower level reservoir empties at the low tide. The upper level reservoir replenish at high tide. So during the low tide, this lower basin it gets emptied, and during the high tide, this upper basin it is replenished. So during the high tide, let's see how the double basin tidal power plant generates electricity. So during the high tide, the wall or the sluice gate it is opened. So as there is a level difference between sea and upper basin, water starts to flow from sea to this upper basin. Here during this, the wall or the sluice gate between lower basin and sea it is closed. The sluice gate between upper basin and lower basin it is also closed. So as soon as the level of the upper basin it is raised and rise, so as soon as the level of upper basin it is raised, at the same time the lower basin it is emptied. It is in the condition of empty. So as soon as the sluice gate is opened, sluice gate between upper basin and lower basin it is opened, the water starts to flow from this basin, upper basin to lower basin, and as there is a turbine mounted, the electricity is generated. So here now the water level of the lower basin it is increased. So as soon as the water level of the sea during low tide is decreased, the sluice gate between lower basin and sea is opened and water starts to flow from basin, this lower basin, to sea. In this way the lower basin is emptied. Again during the high tide, the sluice gate between sea and upper basin is opened and this upper basin it is filled. So in this way the electricity is generated as and when required. As and when required means these are the two basins which are kept at a certain height, certain difference of height between them. So when it is filled, whenever there will be the demand of electricity, this gate between upper basin and lower basin it is opened and the electricity is generated. So in this way the power generation it is here continuously or it is on the demand. Now let us see advantages of tidal power plant. Tidal power is completely independent of the rain and its uncertainty. Large area of valuable land is not required. Peak power demand can effectively met when the tidal power plant works with the thermal or hydroelectric power plant. Tidal power plants are free from pollution. Now let's see the limitations of tidal power plant. Due to variation in tidal range, the output is not uniform. The plant efficiency is affected because the turbine have to work on a wide range of head variation. There is a fear of machinery being corroded due to corrosive seawater. It is difficult to carry out construction of a dam or deck in a sea. As compared to other sources of energy, the tidal power plant is costly. The power transmission cost is high because the tidal power plants are located away from load centers. So this is all about tidal energy and tidal power plant. Thank you for watching this video.